Okay, very good morning to everyone. So, can you hear me? Morning. Okay, so we're now at 5 minutes past 8. So let's give the session a start lah. So the attendance QR code already put on our WhatsApp group. So please take your attendance before the end of the class or the end of the session lah. The moment I finish the session, I'll switch off the QR code. So you won't be able to take your attendance after that. Okay, so for last week and this week, we are focusing on basically a 2D element. So usually, as I mentioned, usually this is the topic when if you still remember, by the end of every semester, you have to fill in this so-called end of course survey. So for the end of course survey, they'll ask you, okay, which topic you think you need more information, or you hope that the topic can be improved on, and so on and so forth. So usually the topic that shows up out of, let's say out of 10 comments, CST will show up easily 8 or 9 times, okay, as the topic that some or most students will feel more challenging or most challenging, or would require, the most common comment is that, please give us more examples. So I have to be honest, there is only so many examples I can give. Okay, there is only like so many examples I can give. I cannot give you like 100 questions for you to try. Even I give you 2 or 3 questions, I don't think everyone will do 2 or 3 questions. That's another problem. Okay, so I cannot give a lot. There's a limited number of questions that I can give. And a lot of them depends on your own effort to actually go and hunt for different types of questions online. Okay, so what I do is I increase the number of questions that you will be going through for CST. So examples also, we have got a number, and then we have a number of assignments, and then after that we'll have your past year questions to try. So easily, on average, you're looking somewhere between 5 to maybe 10 questions overall. But I'm going to discuss only, as you go through the notes, you should know that we have, I think, easily 2 or 3 examples already being discussed. And then there are 2 assignments waiting for you all to finish by the end of this week. Okay, so the idea for today is to highlight the things that you need to take note of when it comes to CST. Okay, also one more thing, we might be a bit short in terms of timing for the second half of the semester. One reason is that I'm spending a bit more time on things like, for example, revision, and also on CST, for example. So I will be releasing the new topic before the end of this week lah, maybe today or in the next few days. The new topic is on heat transfer. So the reason I'm releasing that topic earlier as compared to what I originally planned is I'm worried that the test date might just show up tomorrow and you have your test end of this week, something like that. Okay, this is an example, not to say it's going to happen this week lah. Okay, so like I said in the message I sent out last week, you should expect test 2 to happen in June. Okay, we are still in May, so means definitely not this week lah. Okay, you should expect test 2 to happen in June. Okay, it can be the first day of June until the last day of the semester, which is 20 something of June. Okay, so with our past experience for test 1, basically I think we need to learn from there lah. So means that you need to be prepared for the test anytime. So I don't know why this is happening this semester. Okay, I have no issue. I have no idea, no clue why the school is doing it this way. Okay, I have really no idea. Okay, so lecture side, I've already mentioned to a few lecturers lah, especially those setting test 2 questions, to be well prepared ahead of time lah. Okay, because last time we were a bit we were caught by surprise for test 1 also. Okay, so that's for test 2. So test 2 will be 3 questions means you have one question on beam, one question on CST, and one question heat transfer, which is on composite walls. So that I will release either today or in the next few days. I'll release a topic. So there'll be an overlap between CST and heat transfer topic. So if you're already done with CST, you can start to move on to heat transfer. But I'm not going to cover heat transfer. I'm not going to talk about heat transfer today because I think it's more important to focus on CST. So for the whole topic, there are for the whole subject or the course, there are two topics that you have two questions. One is truss, plain truss. You have one question in test one and you have one question in the final. The next topic is CST. CST, you have one question in test two and another question in the final. Okay. So for reasons that I still cannot really basically identify, CST will always be the question where students complain about time. That definitely is going to be an issue. So if you think test one, you have a lot of questions where you don't have time to finish, wait until you look at CST questions and you will have issues lah, basically. If you're not able to finish on time, for example, for plain truss question, you think that you need more time, then wait until you do CST questions, then you realize that actually time is even more critical for CST. Okay, so before I proceed, any questions or any comments? Anything you want to ask first before we proceed to discuss further about CST? No, so any other things you can leave it until the end lah. Okay, so let me share the screen. Okay, share. Okay. So for any types of element that we learned so far, there's a certain trend. If you go through the notes, how we prepare or how it's being prepared. So the first thing that we always learn is that we need to know how many nodes are involved in the element. So the first thing when you talk about CST, okay, so please take note, CST is a 2D element, okay? Sorry. So let's say if I draw a triangle, okay, so we're going to draw a triangle, okay? So when I draw a triangle, when I put 3 nodes, okay, so CST is a 3-noded element. The one that we're looking at is 3-noded. So if I have 3 nodes like this doesn't mean that I'm having 3 truss elements. Okay, a CST means it's a surface. Okay, so means the middle here is filled up, so it's a surface. Okay, so it's not that this is 1 element, 2 element, and 3 element. It's not going to be element 1, element 2, or element 3. No, so this is wrong. Okay, so CST is a 2D element. Please don't treat it like what we call a truss element. So I do see students do that during the test. So last time, so I was a bit frustrated when I see things like this because I feel like I cannot really understand why students would think that way sometimes. So this is point number 1. I've seen students who treat this element CST as 3 elements: element 1, element 2, element 3. So that's wrong. So in this case for CST, it's a 2D element, okay, which means that it's a surface. Okay, it is a surface by itself. So this whole thing is 1 element by itself. Okay, it's 1 element by itself. Okay, so once we know what type of element we are dealing with, we are doing a 2D, we have 3 nodes. Okay, so 3-noded CST element. So let's say I'm going to label the nodes. Okay, I'll call it node 1, node 2, node 3. So that's the next step that we would do. Then after that, we will have our degrees of freedom. So for CST, it's only displacements, means X and Y displacements, no rotation. Okay, so we are talking about 2 degrees of freedom per node as well. So you have 2 here. So you have Q1, F1, R1. Then you have Q2, F2, R2. So the same thing, the same way we do for labeling means we go by the node sequence based on the numbering that we introduce. So we have 1, 2, then after that we are going to go to, okay, so So you're going to go to the next one. So do X first. So here is Q3, F3, R3. Here will be Q4, F4, R4. Then followed by node number 3, you have X and Y. So here will be Q5, F5, R5, Q6, F6, R6. So then you have so total you have 6 degrees of freedom per element. So from this, you will be able to tell the element stiffness matrix to be a 6 by 6 matrix. So for the stiffness matrix, you will be given the formula sheet. So we'll come to the formula sheet. What are the things that you have to take note on the formula sheet? Okay, so once we know this, so you learn about your displacement field next. Okay, you talk about displacement field. Okay, if you see on the notes, your displacement field, because you have X and Y, we use U and V. So this, from here, we can get our shape function, N2, N1, N2, N3, which is as a function of the xi and eta natural coordinate. So means this is referring to X, this is referring to Y. Okay, so from there, you can get your displacement field. From displacement field, so you can get your stress and your strain property. So you get stress, you get your strain. The different thing about the stress and strain for CST is you have the term D, which is called your material matrix. Okay, if you look at the standard elements that we have studied so far, usually we only define in terms of E, which is your modulus Young or modulus of elasticity. Whereas for CST, we have a matrix known as material matrix. For material matrix, okay, for material matrix, you have two assumptions. One is you call plane stress. The second one, it's what we call plane strain. Okay, plane means NE, not plane as in PLAIN. Okay, so we are talking about plane stress and plane strain. So the next thing that I always see students make mistake is in terms of the plane stress, plane strain assumption. If you get your plane stress and plane strain assumption wrong, it will automatically mean that your stiffness matrix will be wrong. Okay, for those who have gone through the notes, plane stress and plane strain, the components, the matrix, will show up in your element stiffness matrix. So which means that if you get your assumption wrong, so not this one, when you get assumption wrong, your K will be wrong. Okay, so you need to first find out what is the assumption, whether it's a plane stress or plane strain assumption when you read the question for CST. Okay, once this is wrong, K matrix will be wrong, everything will be wrong. So that is the danger of CST. So the first assumption, you need to get it right, means plane stress or plane strain. So plane stress and plane strain, the easiest way to identify is one is for basically for shell or for very thin plate. One is for very thick conditions. So means this is very thin. For plane stress, this is very thick. Okay, so if you have a surface, so let's say we have, this is our thickness. Okay, this is area. Okay, so if the thickness is extremely smaller compared to the area, means it's very thin lah. Okay, then you will have plane stress condition. But if you have, this is the area, and you have this as the thickness, if the thickness is much larger compared to the area, means it's a very thick structure, then you will have plane strain assumption. Okay, so I hope that this is clear lah. For very thin, very thin as compared to the area, okay, then you have plane stress. For very thick as compared to the area, then you have plane strain. Okay, so for, yes, for this question, if it's the same size, actually plane stress and plane strain assumption will give you a less accurate answer. Okay, okay, theoretically, you should not use plane stress or plane strain assumption if it's comparable, theoretically. But if during the test, or for example, in the example, okay, I give you very absurd thickness and area, okay, but then I do state the assumption. Okay, that is just an example lah. I do remember in the examples I give you very absurd thickness, which actually basically it doesn't fulfill the plane stress and plane strain assumption. Okay, those are just examples only. So I just give very absurd thickness, that one. Okay, but for the test questions so far that I've noticed, we will tell you, sometimes the condition will be, we will tell you the thickness. Based on that, you decide. So for you all to decide, we'll give you a very huge difference. For example, I'll tell you, for example, the length is 1 meter and 1 meter, thickness is 1 mm. So in this case, you should know it's plane stress, right? Then if this case, I'll give you 1 meter and 1 meter, and this one I give you 100 meter. Then you will be able to tell that it's going to be plane strain. So for things that we want to test your understanding, for this case, so far for CST, I've not seen anything where we give you thickness is 0.5 meters lah. We don't reach to this point, or even 1 meter lah, okay? So usually we'll give something which is like meters for the area, and then the thickness will be millimeters. That will be for plane stress. And then this one is, we'll tell you it's extremely thick. We'll give you a very, very huge number for thickness. So hopefully that answered the question. So for the test and final exam, so far I've not seen any question that gives you a thickness that is comparable. But for my examples, I do remember the thickness is comparable to the area. But in that question, in the example, I state clearly what is the assumption, plane stress or plane strain, that I want you to use. Okay? So when it comes to the test and final exam, then we will be very clear. We won't give you somewhere 50-50 where it can go both lah. Because in theory, when it's comparable, you should not use plane stress and plane strain assumption. Okay, Ken? Okay, so this is the second part that I hope you all will take note. Plane stress, plane strain is the first thing. Even in the questions, when we set up the marking scheme, so you have to answer first, what is your assumption? Whether the question asks you or no, please state what is your assumption for the question, whether it's plane stress or plane strain. The question might not ask you what is the assumption that you need to make. There's a possibility the question might not ask you. But please write down what is your assumption before you start answering. Okay? So write down. Sometimes just by writing down, you might get 1 mark. Okay? You might get 1 mark by just writing down. Okay, what is your assumption? Okay, so please state down at the beginning what is your assumption. Okay, so later when I go to the formula sheet, I'll explain a bit some of the strategies that you can adopt to save you time to answer CST related questions. Okay, so the next thing that I want to highlight is item number 4 is the type of load. Okay, so you have 3 types of load. You're talking about, we have point load. Then we have, if you look at the notes, we have something called traction. Traction is actually equivalent in this case to pressure. Okay, some of the lecturers, they don't use traction, they call pressure. Okay, you apply a pressure on the surface or the edges. Okay, for example, you apply a pressure on this edge here. Okay, so it's like a uniformly distributed load lah. Okay, so for this one, the unit is newtons per meter square. Okay, and then finally you have body force. Okay, body force in this case is newtons per meter cube. That's the unit that will be given. So for body force, we will tell you to neglect or to consider. If we want you to consider, we will not give you the body force in terms of the newtons per meter cube. We'll give you in terms of density of the material. Okay, density of the material is in terms of kilograms per meter cube. To convert from kilograms per meter cube to newtons per meter cube, you just need to multiply gravitational acceleration. okay, which is 9.81. Okay, so means density times G, which is 9.81, then you get your newtons per meter cube. Okay, so for body force, if you look in the notes, okay, sorry, I don't have much space. I'm going to go up here. So you have, if you look at the notes, I have the X and Y direction. Okay. Okay. So for gravitational force or body force, X actually don't exist. Okay. We only always have in the Y direction. Okay. So I still put the X direction because when you're looking at a different, let's say, I mean, this is not covered in this particular topic for our course. If you have acceleration in the X direction, okay, let's say you're looking at dynamic problem, then you have acceleration A. Okay, so if that case you have acceleration in the X direction, then you have the body force in the X direction, which means it's the acceleration in basically acceleration due to acceleration in the X direction. Only under this case, then we have the X direction body force. But for this subject, for this course itself, we will not be testing this part. Okay, that one I need to be clear. So because in the notes, you can see that if for those who have not gone through the notes, you'll notice later that when it comes to body force, we have the X and Y direction. So, but when we talk about gravity, we only have in terms of the Y direction, we don't have X direction. Okay, so then under what condition we might have X direction? So I already mentioned, means if you have acceleration of movement in the X direction, means you have sliding or acceleration moving lah. The object is moving in the X direction. So in that case, if you have acceleration, then you have your body force in the X direction. But in this case, we will not have it lah. Okay, for our case, we are looking at static conditions, so there will be no movement in the X direction. Okay, so that is what I want to highlight. Okay, so this is the basic things. If you have not gone through it, the notes yet, so please, when you go through the notes, take note of all these items. If you have gone through it, I hope that you get the idea. If you don't understand, hopefully the explanation will somehow make it clearer and not make it worse. Okay, so these are the points that I want you all to take note of. So the next thing I'm going to look at, I want you all to take note of is the formula sheet. I'm going to go to the formula sheet to explain a few things that I want that students also make mistake when it comes to using the formula sheet. Okay, so this is the formula sheet that you will be using. So this is the standard one. So I've given it in the notes. Okay, for this formula sheet, so you have your K matrix, which is your stiffness matrix. Okay, so the first thing that students always make mistake is to forget about T over 4A in front. T is thickness, A is given as your area, which is basically calculated here lah. Okay, so students will always forget T over 4A. Okay, so some is because of examination pressure, some is because they are rushing for time, some is just totally, I don't know, they just don't care about T over 4A. They're just so focused on getting the numbers. Okay, so step number one, T over 4A. Please don't forget about T over 4A. T is thickness, A is the area, which is calculated based on half of the determinant for your J. Okay, so the trick is that the moment you determine plane strain or plane stress, you can already move to calculate your parameter D. Okay, so once you know whether it's plane stress or plane strain, calculate D. Straight away calculate D, D11, D12, D12, D21, and D33. Calculate it at the top. So it will not change because D is for the material. It will be the same for all elements that you're going to investigate for the structure. Because you're going to have basically the structure, one type of material, we're going to split it into elements. So calculate D first. Once you calculate D, then only you talk about calculating the rest of the parameters. So here you have, if you look at it, all the parameters here is in terms of D and Y, D and X, D, X, Y. So it's all about X, Y, and D. So D is the one that will not change for all elements because it's only in terms of modulus Young and Poisson's ratio. Okay. So the only thing that will be different between elements will be your x, all the x and y values. Okay, so Jacobian term is only calculated once also. So means for the Jacobian, the j term here, you only calculate for the element. So based on x13 and x in terms of x and y. So for example, x13 here refers to is x1 minus x3. y23 is y2 minus y3. So x1, x3, these are all referring to the coordinates for the first, second, and third nodes. I refer to first, second, and third. I'm not talking about node 1, node 2, node 3. Okay, I'm talking about first, second, and third. Because your element, if you draw the element, it might be node 2, 3, 4. If it's node 2, 3, 4, then there's no 1, 2, 3. So some students might be just say, no, sir, we cannot calculate our stiffness matrix this way. Because here is only 1, 2, 3. Whereas here I have 2, 3, 4. I don't have 4, I cannot calculate. Okay, so wrong. So this is referring to the first, the second, and the third node of your CST element. So if you label, another thing that I forgot to mention just now is that the labeling or the numbering of your nodes will have to follow the rule of counterclockwise. Okay, means it has to go counterclockwise. So the counterclockwise first, second, and third node, if you do it counterclockwise in the arrangement, your determinant J will always be a positive value, which is larger than 0. So to check whether you have done it the right way or the wrong way in terms of the way you define your first, second, and third node, when you calculate determinant J, if you get a negative value, then there are two possibilities. One is you calculate x, y the wrong way. Another is there's a possibility you define your first, second, and third node in the wrong way, not counterclockwise. So when I say counterclockwise, it can be any form as long as it's counterclockwise. So means that in this case, let's say we go counterclockwise, I can put 2, 3, 4. Okay, so this can be my first, second, and third node for my CST. I can also go 3, 4, and 2 as long as it's counterclockwise. And I can also go 4, 2, and 3. Okay, so I have these three possible combinations that will give me a counterclockwise arrangement. So this will be, in this case, for the first configuration here, so this will be the node 2 will be the first node for my CST element, node 3 will be the second node, and node 4 will be the third node for my CST element. Then from here, you get a first, second, and third. Then you can get your x1, x3, y, and y2, y3, and so on and so forth. So what we do is that, let me see. Okay, I'll go back to the whiteboard later to explain, to come back to this one again. Okay, so this is the formula sheet that I mentioned you'll be using. So the formula sheet, another thing I want to highlight is that it's given in symmetrical form. So you can see that it's given K12 is equals to K21, K13 is equals to K31. So you don't need to calculate all, you just need to calculate, in this case, you calculate the lower half. Then you are good to go. Okay, so that is in the formula sheet. Any question related to the formula sheet? Okay, so I'm going to stop sharing this part. I'm going to go back to the labeling side on especially the counterclockwise for those who might be a bit confused when it comes to the counterclockwise arrangement. Okay, if you do wrongly on that side, then also again, you're going to be in trouble in terms of getting the correct K matrix. Okay, let's go back to the CST element. Okay, so I'm going to label it. Okay, just now I'm going to go, let's say I go 2, 3, 4. I'm not going to use 1, 2, 3 because 1, 2, 3 later you think that it's the same thing. Okay, so we're going to put in our Okay, so if we have basically 2, 3, 4 in this case, I'm not going to start my queue with Q1 because we follow the node. For Q1, if you say node number 1, you're going to have Q1 and Q2 direction. So which means for node 2, you're going to have Q3, Q4. Okay, we just follow the standard way lah. So you're going to have Q3, Q4, Q5, Q6, sorry, should be the other way around. Q3, Q4, Q5, Q6, Q7, Q8. Okay, so the way we're going to do it is you're going to have your table. Okay, so here we're going to have our nodes. And here you're going to have your X and Y coordinate. So we have to do counterclockwise. Okay, so when we do counterclockwise, the first obvious option we have is 2, 3, 4. Okay, so what I usually would do is I have this on the side, an additional column, which refers to my equivalent of node 1, the first, the second, and the third node as a guideline for you when you want to answer the question. So this is the actual node 2, 3, 4. This is your 1, 2, 3 equivalent for your first, second, and third node, which is going to be used for in your formula sheet. Okay, so in this case, if you know your x2, y2, x3, y3, x4, y4, so then you will be able to get the equivalent. So this x2 here will actually mean it will represent your x1 in your formula sheet. This will represent your y1 in your formula sheet because for node number 2, any information for node number 2 is actually the equivalent of your first node in your CST element. Okay, clear? I hope that this is not going to confuse you all further, because if you get this part wrong, then when you go to calculate your stiffness matrix, you cannot get the correct X and Y. Then you are going to struggle. You're going to have a lot of marks being lost because of wrong definition of your stiffness matrix. Clear? Any question on this part? So if no question, okay, then when we come to the formula sheet, that's the next part where let's say for this element, we want to define our stiffness matrix, right? So you have your very big stiffness matrix, 6 by 6. So the front part, you have your T over 4A. So we are going to put numbering on the edges here as usual. So in this case, if I put node 2, node 3, node 4 as the sequence for first, second, and third node, so the numbering I'm going to start with node number 2 first, which is 3, 4. Then node number 3 will be 5, 6, then you have 7, 8. So you have 3, 4, 5, 6, 7, 8. Okay, so you can go to your formula sheet, use the formula sheet and label 3, 4, 5, 6, 7, 8. Okay, and then you can choose what you want to calculate. For example, let's say as an example, our unknown degrees of freedom is Q5, Q7, for example. I'm just saying for example, Q5 and 7. So which means that you can highlight 5, 7, 5, 7, 5, 7, 5, 7. So which means that you only need to calculate K55, K57, and K77. Or in this case, you look for K75 lah, because in the formula sheet, they give you the lower half. Okay, so the rest you can put it aside, no need to calculate lah. Unless you need to calculate for reaction. For reaction, then you need to come back to hunt for the missing components. Okay, so on the other hand, let's say if my sequence here I put still counterclockwise, I go 4, 2, 3. Still counterclockwise, 4, 2, and 3. So if I do 4, 2, and 3, then my labeling here, the first node is 4, right? So 4 is going to be 7, 8. 2 is going to be 3, 4. And then node number 3 is 5, 6. So you have 7, 8, 3, 4, 5. 5, 6 as your labeling. So from there, if we follow back this one, let's say your unknown is 5 and 7. So you're going to calculate, you basically can highlight what you want, and then you go and find the element that you need to determine from your stiffness matrix. Okay, so what else? One more thing. One of the last question that we'll ask, or the favorite last part of CST question, is to determine the stress at, let's say the stress at, I put you a point, I call it P. Calculate the stress at P, or get the strain at P. Okay, or I can ask you to calculate also the stress at Q plus stress at Q. Okay, so the last part of the question for CST, you might have a section to ask you to calculate the stress or the strain, for example, at these 2 points, at P and Q. So the thing about this is that the first key, not keyword lah, the first hint that you need to take note of to calculate stress and strain is the definition of the element or the name, constant strain triangle. Okay, the name is called constant strain triangle. The meaning of this means that anywhere across this element in the area here, the strain is constant. So from the name of the element, we can already say the strain at P and Q is the same. It has the same value because the element is derived based on the assumption that the strain is constant across the area or inside the area of this element. So if your strain is the same, means stress will also be the same at P and Q. So which means that you only need to calculate the stress and the strain for the element. Okay, you use the equation. So strain is, if I remember, is D times B. And your stress is, what's the equation? Can't remember the exact one. There's another term in front for the stress. Oh, sorry. This one is B. This one is Q, sorry. Then this one is D, B, and then you have your Q. Okay. Q will mean you have basically look at the whole element lah. Okay, you look at the whole element and then you find the Q, which after you solve everything. So D and B is given in the formula sheet. The total lah, or the resultant of matrix D times matrix B. So B is also given as a standalone in the formula sheet. So from here, by calculating the stress and strain, so you calculate for the element. Okay, so you don't calculate for any, basically usually we won't ask you at the notes, we'll put in the middle here. Then we ask you to calculate. To calculate that, basically you calculate for the whole element. Okay, so the constant strain, as I mentioned, like the name of the element states, means any strain value in the element is the same, is constant. Okay, so from there you can determine the stress and the strain for the element based on the question. Okay, so I think pretty much that's it lah. Okay, so that's as much as I would like to highlight. And any other things that you want to know? Okay, one more thing before I forget. Because I make a note what I need to highlight. Another thing is thickness. Some questions will not give you the value of the thickness. No value of thickness given. So during the test, please don't come, sir, there's a missing information, no thickness given. So if the thickness is not given, we will provide you another hint. Okay, the hint that is, if it's a straightforward hint, will tell you it's a plane stress or plane strain condition. If we don't give you that, you have to read and find the hint. in the question. Okay, we'll tell you maybe the thickness is large as compared to the area. We'll give you statements like this, but we don't give you any value. So the thickness will not be provided in terms of any significant value, but it'll be provided based on assumptions. So if there is no value given, okay, so okay, I think let me share back the screen. If there is no value given, so there are two ways to do it. So one is you assign a large value or a small value. You can make an assumption, but usually I would say just don't give an assumption. Okay, so if for that kind of question, so you look at your equation. Okay, let's go back to our equation. You will have, how am I supposed to do that? You have F equals to K cube. Okay, and then let's say we put our R in. So usually for the case of CST, when you do your reduce SLE, R should be 0 lah, because rarely will ask you there's a gap problem or whatever. Most of the time that's the case. And then when this type of question shows up, okay, you can keep, my suggestion is keep T as an unknown thickness first. Okay, when you assemble the whole thing, K will be in terms of T over 4A. So you have T in front. And most of the time, the question that comes with this type of question, for your F, there will also be a T there. So the F that we ask, the hint I'm telling you is that most likely it's going to be traction, pressure, or body force. Okay, under this case, if you look at the equation in the notes, there will be a thickness in front. So when the equation you have thickness left and right, you can actually cancel it at the end of before you solve your SLE. Okay, for this kind of question, 99% of the time you'll get this kind of problem. Okay, so if for that 1% of chance that we give you point load, so point load means there will be no T. So in this case, then you have no choice but to give an assumption for T if you have no, let's say if the T value is not given. So for plane stress, let's say if it's for plane stress, then you give a very small value of T. So let's say we have, let's say 1 meter and 1 meter. So you can just give T to be 0.01 meter. You give a very small, easily 2 or 3 orders of magnitude smaller. Then this is for plane stress assumption. If it's for plane strain, then I'll say give as 100 meters or 2 orders to be safe. You just assume a value. Because by the end of the day, as long as you go large value, any value you put, your answer will actually still be the same. Your answer will not be off. It will still be the same value. Okay? So you can give it a try. You just plug in the value. Okay? You give a very small value, a very large value. Your answer, the displacement field will be will not be off far. It will be very, very close. Okay? So alternatively, I would say the best is you keep T as it is. Once you reach your reduced SLE, see whether you can cancel out the thickness T. Okay? So once you cancel it out, then you can proceed to solve your SLE. Okay? So yeah, I mean, in my list of things to share, I think, yeah, really that's the last of it. Okay, so questions, general questions, anything on CST? So CST will be the most difficult question for this whole topic for SEMM 3033. Okay, so if for the rest you think it's already very difficult, then this is going to be even more complicated. So this is my warning to everyone. So any questions before we end the session? So I've already uploaded a video on basically explanation, a bit more explanation on the using the reduced SLE method or using the shortcut method. For those who have gone through it, you should notice that that is actually the basically the answer to your test question, or one version of the test question. Okay, so I hope that is clearer in terms of how to use or how to answer in a more efficient manner. Because some students still calculate everything. Okay, so for test one, you might survive if you calculate each and every number for your element stiffness matrix. But for test two, when you have CST question coming in as one of the question, then I would say your chances of even finishing the question will drop significantly if you calculate each and every value of your element stiffness matrix. So you have to use the reduced method. You have to go the shortcut method to determine your element stiffness matrix and also your stiffness matrix. So means you have to jump straight to calculate for the reduced SLE. So for CST question, we are not so cruel to get you to calculate the full global stiffness matrix. Okay, we will always ask you to go straight to the reduced stiffness matrix. Okay, because there are just so many things to calculate for CST if you want to calculate for everything. So that's for CST. And then the next topic we're going to go into will be heat transfer. So heat transfer questions will always be the easiest. So it's like you go to hell first in CST. After that, then you go to heaven when you see your heat transfer question. It's so easy, and then you'll be flying. So heat transfer questions will be the easiest. Okay, so if you don't score for heat transfer questions, then you are losing the best chance to actually get. It's most of the time it's like a bonus question when it comes to heat transfer question. Heat transfer question is basically the stiffness matrix element is a 2x2 only, and the equations are all very very straightforward lah. Okay, so when I release the notes later, you have to, it's very very easy. It's very straightforward lah. Okay, so any other things you want to ask? Any other questions or comments that you want to give? So once we heat transfer, we have two more topics. Then we'll finish the semester, the topics that we need to cover lah. Pretty much the syllabus for the semester is done. So we have two more topics. Both are on heat transfer. Okay. So one is on composite wall that will be tested in test two, and then the final topic is on cooling fins that will be tested in the final exam. So which means that once I release the notes this week, then I'll release the last set of notes next week. Then you have everything you need to prepare for your test two and final exam. So no comments, nothing. So everyone is good. So means that are you all going to defy the odds, which means that every year students will find it difficult for CST, whereas this year your group you're going to prove us lecturers wrong by telling us it's the easiest topic, not the most difficult topic for CST. Is that the case? If that's the case, then I will tell the lecturer who's going to set CST question to make it more challenging then.
No.
Because he was giving a hint, say that CST question all for the last few so every year it's like we ask the time required to solve the question is very long. So he's considering to make it very short this semester. So if there's no comment and anything, then I can only assume that you are very comfortable with CST. So then we should basically test your understanding to the limit. It's not so bad. I mean, test one, you still have people who get quite decent marks. Okay, so from test one, you should have an idea. So what kind of questions you're going to get. So sometimes the assumptions are given, clear. The difficult part is you have to take advantage of whatever shortcuts that you can take off, you can assume to gain more time to complete the question. It's about time. I don't think it's about understanding. I think most of you get the idea. It's just about, do you have enough time to finish the question? Hmm?
Doctor, I have one question.
Mm-hmm.
For the numbering of note, we can start from number, right?
Sorry, come again?
For the numbering of note,
Uh-huh.
can start from any number, right?
Basically, it has to be continuous lah. So means you can start anywhere.
Oh, okay.
If the question don't give you, you can start anywhere. So which means that for us, the lecturer marking then is a nightmare, in the sense that we'll have we have very different. Every student will assume different ways of numbering. So when we mark, it's going to be very, very difficult for us to mark. So you can start anywhere if we don't tell you, but make sure for CST, I highlighted just now, the sequence must, for the element, the sequence must be counterclockwise. The moment you don't follow the counterclockwise rule, everything will go wrong. Can? Shafiq, okay?
Okay. Thank you, Doctor.
Okay. If you don't give you can label it any way you wish. You don't want to use 1, 2, 3, 4, 5, 6. You want to use A, B, C, D, E, F, also can. But you still need to know that the formula sheet comes in terms of first note, second note, and third note. That's why you have x1, x2, x3, y1, y2, y3. Okay, that refers to your first, second, and third note of the element. Okay, it's not referring to the actual note numbering lah. If you look at your first element, it's 1, 2, 3, so confirm is very easy for you. But let's say if you have two elements, the second element cannot be 1, 2, 3 anymore. Okay, so then you have to follow the counterclockwise rule and get the equivalent of first, second, and third note. So any other questions? So plane stress, plane strain, please be clear about that. Anyone, if you don't understand that, please let me know, because that is also another common mistake. Students use the wrong assumption. The moment I say you use the wrong assumption, your material matrix will be wrong. So which means that your stiffness matrix automatically will be wrong and everything will be wrong. So it means D is wrong, everything wrong. Simple like that. So that's the danger of CST. So nothing. Everyone good? Okay, so I need to tell the lecturer, seems like my students, they are very comfortable with CST. So do be creative. Do be creative. I'm going to drop a hint. So for test 2 and final, you might get more than 3 degrees of freedom, 3 unknown degrees of freedom for the questions. You might get up to 4 unknowns. Okay? So I also mentioned that for Gaussian elimination is only tested, or you only use Gaussian elimination if you are asked to use Gaussian elimination. So from test 2 onwards, the term Gaussian elimination will not show up anymore. So when you have a 4x4 matrix, or you have 4 unknowns to solve in your SLE, so your calculator cannot solve, correct? Yes or no? Unless you use a very high-end scientific calculator. Anyone using Texas Instrument? So anyone using the more advanced version can solve more than 3x3. If you can solve more than 3x3, then you're safe. If you're using the standard version, you cannot solve more than 3x3, correct? So I don't know, I mean, is there a rule by UTM saying that you need to use a specific type of calculator? Okay, so in some universities, they say you have to use a specific type of calculator and the model must be so and so. You cannot use different type for exams or tests. For UTM, we don't say anything. Okay, but most of the calculators that the students use, they can do up to 3x3. Okay, that's the standard one. So when you have a question where you have to solve 4x4, for example, in test 2 and also final exam, which I know you will definitely have that kind of questions. Okay, so and also we are not going to say use Gaussian elimination to solve. No, we're not going to say that. So under that circumstances, so this is the one and only loophole that we are going to allow you all to exploit. We don't say anything, so it's up to you how you want to solve it. We don't care the method for this case. You show us your reduced SLE, if you show us the final answer for this kind of situation, we will not take any action. So I'm not saying anything further, so it's for you to interpret. So when it comes to 4x4, when this question shows up in the test and final exam, which will definitely show up, you show your SLE and you give us your final answer straight away, no questions asked. We'll still mark it as it is. Because we don't tell you to solve using Gaussian. We will not put in Gaussian for test 2 and final. Okay, I hope that I'm clear enough in this case. So how you interpret this statement is up to you lah. Can? So it's up to you lor. Okay. So I'm telling you ahead of time, it's not only 3x3, you might get 4x4, you might even get 5x5 if you are so unlucky. So you have no more guideline, because for all the past years before this, most of the time you see at the question, you can know it's a 3x3 question. But for this time, sky is the limit. Pretty much that's the case. Okay, because for SEMM code, it's not about whether it's online or no. Okay, please be clear. It's not about online or no, because this is the first year we changed from SK to SE. So one of the things that when it comes to SEMM is we remove one of the condition for exam questions, means we are not going to limit the maximum unknown degrees of freedom. So it means that it can be 2, it can be 3, it can be 4, it can be 5. It can be lesser, it can be more. So last time we do have an unwritten rule where we limit, and all questions must be 3 unknowns. But this, once we convert the code to SE, so we all agree that we are not going to we are not going to limit it. So means if you're lucky, you get 2. If you're unlucky, you get 4. So we remove that particular unwritten rule so that we don't limit the way we ask the questions. Because if we find it quite challenging to always limit, if you limit to three unknowns, then there's only so many way that we can ask the questions. So you get lucky, you get 2, maybe. If you get unlucky, you get more than 3. So means it's a two-way situation. You can get questions that is to your advantage or to your disadvantage in this case. By removing that condition, then it can be both ways lah. Okay, you can get a very simple one, or you can get a slightly more complicated one. Okay, so please be clear. This has nothing to do with online exam or no. This is just we find citing the question always 3 unknowns very limiting. It limits the way we ask the question. It limits the types of questions that we can ask. Okay, Ken? So any other things? So again, I need to really stress this question, you have 2 questions. Just like trust, you have 2 questions for the whole subject. Means for trust is test 1 and final exam. For CST is test 2 and final exam. So you need, if you really don't master this, you're going to lose a lot of marks. 2 questions. So you're going to struggle. Okay. So if you find test 1 challenging, you have to do something so that test 2, you know your weakness, and when you answer test 2, you know how to overcome your weakness. Okay. So it's going to get more complicated only lah. It's not going to get easier. So if no questions, then I think we will end this session. Okay, so for next week, we're going to go through. So next week, I'll just summarize things on both the heat transfer topics. Okay, So for next week, we're going to go through the heat transfer topics, both topics at the same time, what you need to know, because the topics are quite straightforward, okay? So they are quite straightforward, okay? So by next week, you should have all the materials to prepare for test 2 and also final, okay? So before I let you all go, a reminder for test 2, please be prepared that we might also face a last minute announcement like test 1. Okay, we might get the dates like beginning of the week, and then you have your test at the end of the week. So we might have this kind of scenario again. Maybe, I'm not saying for sure, but please be prepared. Be prepared. This might happen again. So do your best to get yourself ready. Okay. So you're only missing one set of materials to prepare for test 2. Okay. So test 2, for those who did not or missed the message I gave last week. So for test 2, you have first question is on beam elements. Second question is on CST. Third question will be on heat transfer on composite walls. Okay. So you have 3 questions. And at the moment, I've not raised this issue yet with the lecturers. So question 1 and question 2 for test 2 will have the same marks. Question 3 will have lesser marks. The weightage is lesser. So we might shorten the time for question 3. Okay. And we see how long, because currently the full test should be 2 hours. Okay. So typically for each question, we'll give 45 minutes for the students to answer. But if you give 45 minutes to answer, then you will need more than 2 hours. So that doesn't really fulfill the requirement for our 2-hour test. Test 2 is supposed to be 2 hours. So the current proposed duration will be 45 minutes for question 1, question 2, 30 minutes for question 3. Okay, so this is not final yet, but this will be the proposed time for each question. So I will update you all once we get the final decision from the lecturers, whether are we going to proceed with 45 minutes for Q1, Q2, 30 minutes for Q3. Okay, but the method is still going to be, or the way the test is going to be conducted will be the same like test 1. Okay, so we're going to follow the same method. Okay, so if no question, that's it. So thank you for your time. So I'll see you all again next week. So take care until then. Okay, welcome.
Thank you,
Thank
Doctor.
you. Okay.